So yesterday I have been including the Windows .h for iterating over files in a given input path and to get the current directory the executable is in. And I have made all these enum type devs and struct which holds all the header information. So, but this obviously all gets a little bit clunky right now. So what I would like to do is create a header file and put all these GameBoy header types into that header file, so we kind of have that out of the way. Yeah, let's just do that. Let's see. Header file, what do we call this? Maybe just GB Header.h. That sounds okay, doesn't it? And I like to do the old C style if devs. Danilib is just something that I used to like call all my header libraries because you know it's my libraries, whatever. GB Header H. So then we define it. GB Header H. And if. So this is just so that the .h file is only included once, right? It shouldn't be included multiple times. As you can see, I have the same stuff for the typedef.h here. Let me do this. Copyright the thingy here. Why not? GB header. The version is fine. Includes types and functions to extract information out of GameBoy and GameBoy Color ROMs. And we have created this on the 11th. What's today? Today is the 21st. Fantastic. Okay, so I guess the easiest thing to start with is just take any of these, actually take them all, right, and put them in here. I had like a little thing for profiling. Yeah. So if I included my typedef header somewhere, I just want to use my types, otherwise I'm going to use the default C types, basically. So this is U and 8, let this be U8, right? And then otherwise U and 8 is going to be unsigned char. Hello, hello. So this is just to make it easier for, sorry, where's my head at? Focus. So this is just to make it easier for IntelliSense to show me the right types, basically. Okay, so then down here, instead of U8 version, we can say U and 8 like this, and it will default to whatever, you know, whatever type def we're using. Okay, so GB color support enum. This is pretty much still okay, right? This as well. GB pack type enum. Yeah, I think those. I mean, we already determined that those are all okay to be left like that. So I'm not going to do any changes on these. That's just fine. Okay, and then we have the header struct. One thing to note, all these enums default to an integer, so we're kind of wasting a little bit of space, but I mean, it's not much. We're talking about a Windows machine here anyways with ginormous amounts of RAM, so who cares, right? And we're going to be reusing this struct anyways for every new ROM, since we're not multi-threaded. So we can just leave that as is. That's just fine. Destination, and then here we have the version. Okay. So now it would be nice to have a nice function like this one, read GB header, where we basically read the header information out of a chunk of bytes. I want to make this a bit different though. I don't want to have the file reading within this header, right? Basically, I just want to construct something that can be used anywhere. So let's say, so read GB header. And what we're expecting is a uint8 buffer, so something like this, right? We have a buffer size. Size t, where's size t defined? Oh, that is in the VC runtime. Bummer. Ah, that is annoying. Well, that's okay. Let's just make this fine. Uint 64, why not? And this is going to be so we have the buffer and the buffer size. We just assume that the header is starting at the beginning of this buffer. And we have the maximum size that we want to read out. Okay. And then, I mean, basically, this cannot fail, right? The only time this could fail is if the buffer size is too low. So we probably want to report that. I mean, we could just go with an int, right? So an enum. So what we can do is type def enum GB read result. Right. And then we can specify. So we either have success or failed. failure, failure. Yeah, that's fine. We should maybe switch those around, because so we can do this like that, and let's make this an FF. So, reason why I just define this as null is because in an if, a null is always false, right? And anything else will be regarded as true. So failure should be 0, 0, and then result success is just FF. That way we can just treat the result as an int in an if statement in C, and that's it. And then what we want to pass in is the GB header as a pointer. So we already expect the user to pass it in. And then we just assign the values basically depending on what we're reading out of that buffer. So a few statements. If buffer is null, let me guess. Null is defined in the VC runtime. Okay, cool. Well, we can just do this, right? If buffer is null, then we return a GB read result failure. Then if buffer size, right. So the size of the buffer needs to be as large as the header, at least, right? Because that's all the information we want to read out. So it should be this. So if it is smaller than this, it probably is not a valid header, right? So at some point I could return a different error message here so we can distinguish between, oh, the buffer is null or the buffer size is this, right? Well, we don't really need to right now. Let's make it like this. Okay. Or of course, if header is null. Probably put this first. So if either of these statements is true, we fail. Okay, and then we can just basically read the header as we did before. So we're ignoring the file stuff right now here. Don't care about this. What we care about is this kind of stuff, right? And we should probably export these defines here as well. So GB header start and GB header end. And really what we want is this. Okay. So let's put main over here. So we have them both on the screen. Let's hide this shebang. Don't need the files right now. Okay. So let's remove this and okay. So we're starting from here. Let's just copy all of this. Chop into here. Cool. So title size, let's just make this an int, whatever. We can actually use size t because we do need to include the C runtime because we have string copy here, right? It's a tiny bit annoying, but fine by me. Does that mean we can use size T? Yeah, we can. Okay. Let's use size T then. Do I have it anywhere else? No, that was the only. Okay. Right. So size T, title size is 16, and now we kind of need to adjust our buffer positions, so the index. It's no longer at this position, right? Because we're treating this as if we were on 0, index 0. So we're basically at the start of the header. So instead of address 100, we're treating that as 0. So instead of 103, it would be just 3 for the entry point, right? The logo would be from position 4 to 33 hex. And so this means here, that would be position, well, just this, right? Yes. So we have the color support code, which we're setting like that. And to be fair, we should probably do this a little bit different. So let's set header color support is this, right? And we're translating this to GB color support T, right? Cool. And I can switch over this. If it is compatible, we are doing this stuff. If it is exclusive, we're doing this stuff. And here we can see that we can actually combine those two. So either if it is compatible or exclusive, if it is either of these two values, we're just decreasing the title size by 1, because then we only need 15 bytes for the title, right? Or if it is anything else, we specifically set it to color support none. I think that is okay like this. I think that reads quite nicely. Yeah, GameBoy color support. Note. This also determines the title size, e.g. 16 or 15 bytes. Should probably set this specifically to 15 instead of just decrementing it. Okay, we have a to-do here. This might include the game code. I do not exactly know how to fix this quite yet. So let's just ignore that. We'll copy the title again. The buffer is 17 large here. Let's make this a define as well. So that way, if we ever decide to change it, we can just recompile the whole file and it automatically is, anywhere. So, yep. Okay, so the starting position again changed. We are on 34 instead. and we're using the title size from whatever we determined up here. Yep, that is okay, I believe. Then we have the header code. Again, we can make this defined as well. GB header code buffer size. Let's just call it size instead of buffer size. Cool. Code size. Code size is 5. Again, address is no longer at 100, but just 3F, right? And here we have code size -1. Okay. Read game title and make a code. Sorry, game code, not make a code. Make a code is further down. Cool. Now this can stay the same, except obviously the address. This is the Super Game Boy support. Super Game Boy support. We set the... Okay, yeah, if we have a 3, we set the super support to super support enabled. Otherwise, if it is anything else, we just set it to disabled. Yeah, that's perfectly fine. So here we have the pack type where we're just casting. So if we have invalid values in there, we don't really care that much. Same for the destination. But of course the addresses. So it's full. There we go. Fix that, and then we have the version, which is just this. Okay. And then we have the maker code down here. Okay. Read old style or new style maker code. So again, the buffer address is 4B, no longer 104B, and let's define that as well as GB header maker size. You just chose an arbitrary number of 25 characters here. Oh, no semicolon. Sorry. Why the double spacing? It's the little things that I get hung up on. Anyways, okay. So we have a fixed string here, so these will be all in the ROM. That is fine. Buffer 4B, yeah. Otherwise, it is maker unknown, which is okay. And then we copy that in here, which change the 25 to the GB header maker size. Okay, cool. And then last but not least, return GB header read results. Is that what I called it? Nope. Already forgetting names. Fantastic. GB read result. Let's make it header read result. It's a bit of a mouthful, but whatever. So we have failure or we have success. Cool. Right, now the only other thing to adjust is this one. So a U16 is a short, so let's quickly define that. This is a UND16, which is U16 if we have my header available. Otherwise, we just define it as UND16, which is unsigned short. Obviously, this might not be true on like some other systems if you're porting it somewhere, but we don't care about this one for now. I'm just using this for Windows only anyways. So do not give a crap. So UN16, we have a buffer at this position, cast it to UN16, shift over. We do the same with the next position. Now we have a number that is made out of 2 bytes, which we interpret as a UN16, which we can then switch over, and then we have the new maker code, which we then can assign. So once we assigned the maker code to something valid, we just copy it into the header maker, and then we're done. Cool. And this is our read GB header function now. Well, this is coming together, isn't it? Okay, now we have a header that we can reuse anywhere. So even on different projects, if we were so inclined. Now all that matters is we include it. GB Header.h. And voila. Okay, now let's get to the read GB header function down here. So we can remove all of this. Right. No, hang on, this is print. GB header read. So here we're still opening the ROM file, we read the buffer or whatever, but now what's changed is we are using the new method that we wrote down here. So we can do this. I named it the same, didn't I? This is annoying. Maybe they should be named GB read header anyways. And it should be read header result. Sorry, I'm always a bit finicky with the naming. Always change stuff around. Yep. And then down here as well. Read header result success. So I guess to be completely correct, what I should also do is check if these have errors, right? So if this is not null, then it should return a failure as well. Because technically those could fail. Okay, we have a string copy here, string copy here. another string copy down here, I believe, right? Yeah. So I think it is null, right? Let's just verify that real quick. 0 if successful. Nice. S truncate if truncation occurred, otherwise an error code. Right, but we do not enable truncate because we exactly want that amount. Should be fine. Okay. One other thing, which I think is just good form, is to separate the implementation from the definitions in case I wanted to pack this into a different translation unit, I suppose. So let's follow the same guidelines that I set out before. So if what did I call this? If this is defined, we chuck in the implementation. Otherwise, we just have the definition. This has the negative side effect that I now, before I import the header, need to do something like this. Right? I need to specify that I want the implementation in here. So this is basically something I do for header-only libraries. If you have ever seen the STB header libraries, header-only libraries, this is where I got the inspiration from. So STB header-only libs, right? From nothings. You can find that on GitHub right here. So basically that is a collection of libraries that I just implemented with a single header file. No C file, no lib file, or anything like that. You don't need to worry about importing a bunch of stuff. You just chuck in your header, and then you just use it wherever you want to. And I really like that idea because it simplifies a lot. You know, you just point to one file and said, hey, include this in your project, and you're ready to go, right? No whole setup or introduction of how to like import your library and set it up so you can use it, which is great. The easier you make things for users, the better. Ooh. Okay. By the way, Sean Barrett, I think, sorry if I mispronounced that, but he has worked on Thief, I believe. So the original Thief game. So this dude knows what he's doing. Definitely worth checking this out. Anyways, this is sort of where I got my inspiration from if I do like header libraries. Hey yo. Okay, where was I? We were trying to use it. So now we have the header, and down here, right, I named it the same, which obviously won't, I should name this something else, but this would be GB read header now, right? So sorry for the confusion for the read GB header and GB read header. Okay, so now how do we use our new function that we just defined. So as you remember, we pass in a buffer, and we're getting a buffer right here, right? We have a 4 kilobyte buffer that we read out of the file. 4 kilobytes because I know this is the sector size of my hard drive, which means it's the most efficient file read that you can do, because you're reading exactly the amount that the hard drive gives you when it tries to read a file. So we can just pass in that buffer, but if you remember correctly, we want to have the buffer at the position where the Game Boy header starts now, because we no longer care about the stuff before, right? So what we need to do is we need to advance. So the buffer points at location 0 of the file, right? So we need to advance it to the position where the header starts. And where does it start? Well, we have this wonderful define here, GB Header start. So we're just advancing the pointer essentially by however many bytes to the start of the header. So this means whatever we're passing in the buffer starts at exactly the right location that we need to. Now, the buffer size, how big is it? Well, we have specified here 4 kibs, right? So we could just pass that in, buffer size. However, because we advanced by this amount, we should probably just subtract it, because we're no longer passing in the beginning amount, right? And then we're just expecting a GB header out of this. And you see we already have a pointer here, so we can just basically pass it further down the chain. So now, if, and this is the nice part, if I can do now this, if this should fail, then I can basically print out an error message, right? Now, it would be nice to distinguish, was it a CRT error, because we copied the string. Ideally, what I would like to do at some point is remove this dependency, right? Actually, let's make it to do. Remove this dependency so we are no longer tied to CRT errors. So at the moment we cannot distinguish, is it like just an error for the usage because we passed in the wrong parameters, or is it actually an error you know what? Probably the best thing to do would be to have these as asserts, because like you don't want to check these during runtime all the time, right? Yeah, I think an assert would be okay. How do you do asserts in C? Let's see. Assert macro. Okay, just assert and an expression. Evaluates an expression, and when the result is false, prints a diagnostic message and aborts the program. Cool. Where is the message though? I can only see assert and expression. Okay, which... okay. They have their own assert messages. Okay, cool. That's all fine and dandy. Where do I find this? In assert.h. Okay. Double include, why not? Assert.h. Now this is including core crt.h. Okay. Oh, but they have this nice macro here, and I kind of like that. So let's just use that. Why not? I mean, does it really matter then if we would remove this dependency? Probably not. I think this is fine to have. Maybe. Okay, assert. Assert buffer is not 0, right? Assert header is not 0, and assert that buffer size is bigger or equal to this. What? A simple file is not okay. Why would you care about that? Okay. So we have an expression. Not. Okay. Wow. Jesus. Okay. Macros are fun. All right. Let's just take it as is. So now whenever we actually return read header result failure, we know it's gonna be a CRT error. So what we could do here, yeah, let's just do print CRT error, fail to read GB header from file. Let's make it like this. And then we should do results, and then we name this cleanup. Go to cleanup and go to cleanup. And return the result, and if we are in here, then result is true. Cool. So now, why are you complaining? ROM file could be 0. Well, so reading still works with the new thing that we just created. I'm just baffled why it thinks this could be 0. Oh, is it because I'm trying... Let's maybe make this a white version as well, if there is such a thing. VS... Oh, I hate these names. I hate these names so much. Yeah, that's easy to remember, isn't it? Underscore VSNW printf s. Sure. sure. Okay. Let's make this a W char. Okay, so where was I here? So this is now a wide string. No, it still complains. What makes you think this could be null? Wait, what are you complaining about? ROM file could be null. But if it is null, we surely return an error, no? Okay, I mean, I can make another null check, why not? Cool, at least it stops complaining then. Okay, fine, whatever. So, and if we start this again, we have our outputs. Yay, okay, so our header file worked. Fantastic. And I thought I set my watch to silent, but apparently I did not. Oh well. Cool. Function definition print GB header not found. But it is right here. And clearly it's been working, right? I have been compiling. Or did it run like some older version? Let's see again. Rebuild. Rebuild all succeeded. Well, there's a lot of warnings. Which I should probably address at some point. Yeah, okay, this is like casting between different string types, which is fair. I just changed it to a WCHAR. So, there we go. Okay, rebuild. Rebuild all succeeded. Okay, 30 mornings. GB header struct 1 bytes padding added after data. After data member maker. Interesting. And 3 bytes padding added after data member version. I mean, yeah, padding is fine. I don't give a shit about that. I'm expecting that, so I'm not sure why it's warning about it. Why are you warning about it? This warning is off by default. Clearly it's not. What does off by default mean? Visual Studio. Okay. I wonder if I do this. Okay, well, fine, we can increase this to 26. So at least it will stop complaining about that one. But otherwise, I mean, that there's padding after version, I really do not care. So let's disable that one. Properties, I think here, disable specific warning. Let me just type in the number, I think. Right? Nope, that wasn't it. Do I have to leave that? Even my dog doesn't like this. Did I set it even on the right thing? No, I only ignored it in release mode. Okay, fine. All configurations. Yes. There we go. Will you accept it now? Rebuild. Invalid numeric argument. Oh, for crying out loud. Okay, then without the C. Apply. Rebuild. Fantastic. We got rid of it. Okay, what is this? Function. Const char differs in direction to slightly different base types from U8. A? Oh, because it is unsigned. Who cares? Why do you care? Oh my god. Fine. Make it a char pointer. Are you happy now? Jesus. Okay. GB color support none is not explicitly handled in case label. Yeah, because we have a default. This is one of those useless warnings. I mean, I did have warn all enabled. It's my own fault, I suppose. Fine. I mean, we can just do this. GB color support none. Right. Are you happy now? Warning C4061. Cool. That should do it, right? Now, incompatible types. This is more serious. From wchar_t to char pointer. Where? What? It goes to print headers, but print headers. I didn't change the definition. Okay, and print Windows errors. Did I change that as well? No, that is still a char. Do I want to change that? I probably should. Okay, let's make it all white. Oh dear lord, this was this one. Cool. I hate the naming conventions so much. This is const w_t, right? LP void, because this is LP TSTR, which is LP WSTR, which is w_t, which is w_t. Okay, cool. Yep. Right, but now we have these error messages, which need to be white characters as well, because now it's complaining, right? Which is fine. Let's just make it white. What is these squiggly lines here? Function definition for print GB header not found. Is this like just a bug? No. What are you doing then? Print GB header. I mean, it's right here. Unreferenced. Ooh, pardon me. Unreferenced formal parameter. Ah, God, yeah, I hate those. I think I'm just gonna disable that warning for now. It basically complains that we haven't used those arguments here. Actually, we will be using them later on, so I'll just ignore the warning for now. Okay, incompatible types from whrt to const char. What? Where? Oh, P error. Is it PW error, WP error? No. Is it P error W? Nope, none of these. What is it? It's underscore WP error. How could I forget? What a convenient name. Jesus. Okay. Formal parameter, one different from declaration. Is it? Print Windows error. Indeed, we now change that. That is true. Incompatible types from char to whrt. Where are we doing that? No, we don't. Okay, this is probably just at different stages. Okay, what are you complaining here? Again, it complains that we're not using none, which, you know, whatever. So GB color support none, which just falls through to default, whatever, doesn't matter. It's the same warning as here. Then the same here for disabled. case GB super support disabled. There we go. Let's change this to enabled. Okay. It's good to sometimes clean up the warnings, at least. Okay, one more incompatible type. Yep, that is correct. And what? Why did the other one just disappear? What? Cool. Okay, only 2 warnings, which is the arguments because we're not using them, which will change, hopefully, right now. Okay. So we put our GB header reading into its own separate header file. We cleaned up all the warnings. Well, I still don't know why these squiggly lines are here. This seems like a very shitty persistent bug for some reason. I don't understand. Why are you complaining? It's not even used up here, it's down here, so are you happy now? No, you'll never be happy. Okay then. Well, I can't help you to happiness. Okay. What should we do next? I mean, the printing code could also... no, actually, it shouldn't go in there because this is entirely part of the program, right? We want to write the CSV file, comma separate with values. Yeah, let's do that. So I like to have defaults with my applications, right? So at the moment you can just double click it and it just happily executes. It goes through all the files that it finds within the same folder that you launched the executable from. So this is why we have the current directory here. And equally, if we do not specify an output file with either of these arguments, I just wanted to create a default one, right? Why not? We want as little how do I say this? We want it to be as easily usable as possible, right? So output path. Let's make this max path as well. Although with Unicode characters, I think max path is a bit too short. It can be way longer than just 260 characters. But whatever, let's set this as a limit now, and if it becomes a problem, we can always change that. Probably won't become a problem since I'm using the English version of Windows, right? I'm not using any fancy Unicode characters. I should probably test that at some point. I don't know, use some kanji or something for a folder name and try and see what happens. Okay, so output path. What we then can do is we have our fancy combined path method right here. So function, sorry, and we want this to be in the output path. And the first segment will be the input path. And the second segment will be just the file, right? So let's call this output, comma separated values. There we go. As easy as that. So, and if this fails, does this already print P errors? I always forget. It does. return exit exit failure. Okay. So, and we can also display our output path. So output file actually, and it will be output path. Right. And what did I fuck up? I mean, it returns a bool. Ah, I don't have, right. I don't have the definition right up here. Okay, cool. I know it all looks really messy right now, but we'll get to it. So, output file, and what the hell is this? Right, because we haven't set this as a white character. Right, there we go, output CSV. Cool. So we will just have an output CSV file in the same folder as we're iterating through, which is fine. Okay. Now instead of print headers, I probably want to call this read ROM headers, and I'm putting a little R in here for recursive as preparation. I'm not going to implement the recursive version just now, but you know, I will at some point. Right, so here, read ROM headers. So these are all helper methods really, and we have the actual program execution. Okay. So we're calling read ROM headers on the input path, and we specify the output path as well. I'm going to pass that in. Actually, let me think about this real quick. I probably want to write everything in memory first. So all I really want is some kind of output buffer, right? Where I just dump everything in. How big would that be? We don't know, depending on the files we have, right? So we probably need to dynamically allocate it. Okay, let's do that. So let's say we have an output buffer. It's a U8 pointer, and we're allocating it with malloc. The size of the output buffer what would that be? Let's just make buffer size. Why not? There we go. Actually, we can probably make this a little struct. Let's do that. Okay. Sorry. Type dev struct. Let's call it the output buffer. buffer t. Let's call it dynamic buffer. Dynamic buffer. We have a U8 pointer of buffer, which can be any size. So we have a size t of the actual size of the buffer, right? And then, because we also need to keep track of how many elements we've already written, we also have the capacity of the buffer, right? So this will be how many bytes do we actually have, how many bytes have we written, and this is the actual bytes. So if size and the capacity, if we have written as much as the capacity, we're just trying to reallocate a new buffer by, let's say, doubling the space that we have, right? So we can write more data into it. Essentially, if you've ever worked with C# and used the list, that's basically what happens under the hood. It's just basically an array that you fill stuff in, and at some point, the size equals the capacity, and then they just double the space. So we're just gonna do that. Okay, let's call this init buffer, a dynamic buffer of t. And what we're doing here is we say buffer capacity equals buffer size. Buffer size equals 0 because we haven't written any elements into it, and then buffer, that's a shit name, isn't it? Let's call it data. The buffer data is, we'll allocate something, and the size will be of buffer capacity. And since it's just U8, so it's just bytes, so if we just pass in the capacity itself, that's perfectly fine. Then we need to do a little check if we actually have allocated that buffer. So if it is null, then something went horribly wrong. So we probably just want to fail to allocate buffer, whatever, into std error, and we return false, otherwise we return true. Okay, so this is how we initialize our buffer. Then obviously we also have, actually, let's call this buffer init, dynamic buffer init, and we have dynamic buffer free. Dynamic buffer t buffer, and we need to free the data that we just allocated, so buffer data. Cool. And then we could also have dynamic buffer resize. Nope, let's call this dynamic buffer grow. So we want to grow the buffer because we need a bit more capacity. What we can do is then just say size t, this is our new capacity, which will just be the buffer capacity times 2. Then we have our new data, so, and we will use realloc. Realloc is kind of special, so it will basically try to allocate the double capacity that we just specified, and then copy over the data that has already been written into the newly allocated buffer. Now there's a kind of a special case, so it first tries to just allocate, new space exactly after the buffer that we've already allocated. So it doesn't need to do copy at all. If it doesn't have any space there, it will just do it somewhere else in memory and then just copy the data over. So, here we have buffer data, because this is the one that we're trying to reallocate, and we're trying to reallocate with a new capacity. There we go. So if new data, however, is null, something went horribly wrong, right? And we can just say fail to grow buffer, and then return false. It is up to us to free it then, so the old buffer data will still be available, I think. But we're freeing at the end of the program anyway, so it's fine. So now, coffee time. I'll finish this, and then I'll probably take a little break to get like some coffee or something. Also, I'm kind of feeling a bit peckish, so maybe gonna eat real quick. But let's finish this. So now we have the new data. All we then need to do is go buffer data equals now the new data, right? And here we have capacity equals the new capacity. Now the size will stay the same because we haven't written any new data into this in the meantime, right? Okay, so this is our buffer. So now let's allocate our dynamic buffer T, our output buffer. Let's just call it output. Why not? Then we have dynamic buffer in it, and it's the address of output. Right. And if this fails, we just return with exit failure. Okay. And then we just pass in our output. And then what we would do here is write output to file, right? Write output buffer to file. If this fails for some reason, we can still write the output buffer to the file, I suppose. Let's just do it like this. Make a little to-do note in here. Okay, so read ROM headers now accepts a dynamic buffer. Read ROM headers. Output. Okay. So I was thinking about this yesterday a little bit. I'm not sure if I want to have the search power of really just look for these file extensions. Maybe it should just try to read out any file. But for now we can leave it like that for test purposes. Because I don't know, maybe someone has renamed their ROMs to just .bin or something, I don't know. I don't want this tool to be too constrained. after all, we can just read out any files. And what we're doing while we're reading the file anyways is, what was it? So right here, we're trying to read 4kib, right? And if we actually don't manage to read that amount of data because it is a smaller file for some reason, then we just, you know, it's not really a GameBoy ROM anyway, so we're just gonna skip that one. Now, if it is a bigger file and it might be something else, I don't know, like a Excel file or whatever, then we just trying to read the header and some gobbledygook comes out. It's fine with me, to be honest. Yeah. Okay, so what do we do then? We go in here, we read the GameBoy header from the input buffer and put it out into the header. And then when we go to printing, instead what we're doing is, actually let's move this as well, and this. So instead of printing out the header, I mean, I leave this in for now, but what we then can do is write into the output buffer, right? So let's make a nice function for that. Write GB header to output. Yeah, why not? GB header T. We have a header, and we want to write it into the dynamic buffer T. Now we could have asserts in here as well, I suppose. Didn't include it, did I? Wait, hang on, it should be included with GB header. Yeah, okay. Wait. Yeah, okay. And assert that buffer is not null. And assert that buffer data is not null. And then we can do our writing right here. One of the things before that is probably we should write, so CSV files usually have like a header, or they can specify a header if they want to. So the first row would just be the header row. So we could write that. So why don't we do that? Wait, that writes into the file stream, doesn't it? That's not what I want. So our destination will be output. I see. I need a I need a function for this. Hang on. So bool dynamic buffer write. So we want to write something into the buffer, and what we're trying to write is comma separated values, right? So what we can do is just say char value, right? Yep, let's just try that. And how we're writing it is with str on copy s. So the destination will be our buffer data. The size in bytes of buffer data is buffer capacity minus buffer size. The source will be our value, and then we have value size as the size we're trying to write. Okay, but this is the buffer size, or let's just better name free space. This is the free space we have in our buffer, right? If the free space is smaller than this value we're trying to write, we need to grow our buffer. So what we're doing then is we call dynamic buffer grow and put in the buffer. Bam. Right, I can do this. So, and then free space needs to be recalculated, right? Because now our capacity has changed after this call, and then we just say free space. Okay. This will copy our data over. Okay, I'm not going to worry about failure codes for this one just yet. After we have written the data, we need to change the size and add the value size into it, because that's the amount of data we have written, right? Actually, I wonder if mem copy would be better. Actually, you know what? Let's make it this way. Let's calculate the length. strlen s, no, just strlen out of value. So we have the value length, and then we can say here length, and we add the length right here. Okay, after we have written the data, we should probably do another check as well. Do we need to? I was wondering if I should regrow the buffer, but I mean, we're checking it in the beginning, right? So probably not that big of a deal. Hey, thanks for the follow. Okay. Yeah, let's not worry about growing afterwards as well. We're growing pretty much on every write call here, so that's fine. Okay, let's write the header. So what we would do is dynamic buffer right, pass in output, and let's just write our header. What do we want? We want file name. Well, let's look at the header struct. How about that? So I want the file name first, so we know from which file the header actually came from. Then we have the title of the game. Then we have the game code. Then we have the maker. Then we have Game Boy Color, Game Boy Color. What's the shortcode for Game Boy Color? I don't remember. I know the original is DMG. It's Color Game Boy. Okay. So Color Game Boy support. Then we have Super support. Let's call it Super GB support. Then we have the pack type, the ROM size, RAM size, and the destination. Oh, and of course the version. Ha. Okay. We should add a new line as well. Okay. Nah, it's fine like that. So this should write our header into the buffer, and if we add a breakpoint here, well, we still have build errors. What did I do? Right, I'm trying to use this before I actually define the types. That is hilarious. Okay, this probably needs to be in its own header as well, but for now, let's just do that. Okay, what else? Right, this needs to be a pointer. Okay, don't have these, but output. Yeah, we have data. The size is, hang on, 106, which is probably correct. It's probably 106 characters. The capacity is 4 kilobytes, and as you can see, if you look at the data, it actually contains file name, title, game code. So exactly the thing that we just written, and then a bunch of garbage at the end. Cool. So now what we could do is write this into the CSV output file, right? So let's create a file here. Let's call it output file. And what we do is fopens wfopens. No, what was it? I just copy it from down here. How about that? There we go. This is the output file. We call this output path, and we want to write binary. Right. free the dynamic buffer. And we also, whoops, what did I do? We also need to free it in the end right here. And I could do a cleanup thingy, but this is just hacked in now anyways, so whatever. Let me quickly check the write mode. Open its empty file for writing. If the given file exists, the contents are destroyed. Excellent. So it recreates the file all the time. Excellent. This is exactly what I want. Cool. And B for binary mode, which is also fine. Cool. So all that we need to do now is call fwrite. Our source buffer. Our source buffer will be output data. The element size is size of U8, right? Now the count that we need to write will be output.size, right? And then the file stream will be output file. Okay. And of course we could also say if this fails for some reason, you know, fail to write to output file, sure, output path. Oh my god, I can't type. Okay. Okay. So let's just disable the ROM reading for now and just see if we get an output file. Failed to write to output file, no error. I must have misunderstood what fwrite is doing. Return value. Returns the number of full... okay. Okay, right. It returns the amount it has actually written, so if it is not the same as output size, then we should return an error. Okay. Cool. Output file CSV, and now we can actually have a look at the output file. This is under projects, VS projects, GB Header Extractor, and there we go. Output CSV. And if we try to open it, okay, apparently I've never started this program whatsoever. Sure. I see, it gives me a bunch of options, but I can already see that it has the right... Okay, there we go. Did you know next to what? No. There we go. File name, title, game code, maker, color gamer support, whatever. Okay, so we have our header, which is pretty cool. And now we can basically just go through the files and put all the data in here. But as I said, I'm getting a bit peckish, and I definitely need another coffee as well. I think I'm going to take a break here. And when I come back after some food and coffee, I think we can get all this data of the ROM files written out into the CSV file. And then we can probably deal with, command line arguments, because we want to be able to specify an input path with a command line argument and all this kind of stuff. but that will come later.